of our Unit 9 on solving quadratics. And remember, this is different than last chapter where we graphed quadratics, but we have the same end goal and we want to solve them. So by solving them, we're finding where they hit the x-axis. Remember, these are called roots, zeros, and solutions. So if it says to solve the quadratic, I'm asking you for those. So remember, we set them equal to 0. And so far we've been talking about using all the ways we factored in Unit 7. Okay, so for number 9, probably should do 7 and 8 first. Okay. So for number 7, I moved over the negative 4x, took out a GCF, and then solved them for 0. Remember that, or set them equal to 0 rather, and solved. So remember that if there is just that x out in front, that means that it's equal to 0. If it was a 3x, 4x, 1/2 x, it does not matter. You will always get the same outcome of 0. Additionally, number 8, that one, you wanted to move everything over to the left side, and then you're able to factor. So remember, you're asking yourself what multiplies to negative 54 and adds to a positive 3. Okay? So we factor and set those both equal to 0. Number 9, we went over that it already was factored for you. So you just had to set each of those factors equal to 0 and solve. I noticed that some of you were stopping once you got to this part right here. Remember, I don't want to know what 4t is equal to. I want to know what t is equal to. So make sure you divide. Okay, I did that last step. Okay, and for number 10, you had to use grouping. You had to factor by grouping. Okay, so remember that. You multiply the first and the last, and you want to know what multiplies. Remember, this is our x method. So what multiplies to negative 14 and adds to positive 13. So that would be a positive 14 and negative 4. Those become your new x values, which are what I have right here. Okay, we take a GCF out. Then we get our common factor, so x plus 7, and then the leftover out in front would be our other factor. Set those both equal to 0, and you have your answer. Okay, so the next method that we're going to talk about has to do with square roots. So next lesson, we will actually learn this method, but before we get started on that, I thought it was appropriate that we go over how to simplify square roots and radicals. All right, so before we get started, I want to go over all of the perfect squares. Okay, so the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, 16 is 4, the square root of 25 is 5, 36, 9, and again, a couple chapters ago I told you guys, now I'm not going to force you to memorize these, but it really makes your life so much easier if you can recognize them. I'm going to write this one better. This one's 121. And remember, all this means is what times itself, okay, equals that number underneath the square root. Okay. 17 squared would be 289. And 324. This is 19, and this is 20. In the past, I told you kind of no to here. All right, numbers 1 through 15. All right, I would just memorize those because, it just makes your life so much easier when you can look at those numbers and you recognize them. All right, so when simplifying radicals, what you want to do is, and this is again why it's so important that you know those perfect squares, because if you know those perfect squares, you can start dividing out your radicals. Let me explain what that means. So we're going to find the largest perfect square that will divide evenly into the number under the radical, which is called the radicand. Okay, this means when you divide, you get no remainders, no decimals, no fractions. Okay, so if you did do, the square root of 48, you see that you get a decimal. Okay, so what you're going to do instead is we're going to try to simplify it so that the number under the radical, which right now is the 48, is a little bit smaller, but you're going to have some left over in the front. So what I recommend you doing is something like this. So you take the number 48 and you're going to start dividing out perfect squares. So 1, I'm not going to do that. So I'm going to divide it first by 4. Okay, well 4 and 12, I know that that's probably can get lower than that, so I'm going to keep going. So my next perfect square is 9. That gets me a decimal, so that's not right. My next perfect square is 16. Okay, 16 and 3. Now that is way better than 4 and 12, so that's the one I'm going to go with. Okay. So again, if the number under the radical cannot be divided evenly by any perfect square, your radical is already in simplest form and cannot be reduced further. So what I will say is a number big like this, not that 48 is large, those numbers are most likely going to be able to be separated a little bit more than that, be simplified. Okay. So the next thing you're going to do is you're going to rewrite the radical by their factors. So we just found that 16 times 3 is the same thing as the number 48. So 16 times 3 equals 48. So we're basically going to break this apart until we can get our answer. Now always make sure that you put your perfect square in front, and I'll explain that in a minute. So now all of this is under the radical, but what we can do, all right, is we can actually split those two factors up evenly. So then we have a 16 and a 3. Well, I know that the square root of 16, that is a perfect square. So now what you're going to do is you're going to simplify. And again, I'm just expanding on, so here's where I started, here's the next step, here's the next step, and here's your final answer. Okay? So now you have your answer in simplest radical form. Alright, so make sure that you fill this in on your paper. Yours just has the arrows, so I'll put little boxes around what you should be putting. So the number out in front is called a coefficient. So it's very similar to if I was writing like 4x, this would be the coefficient. That radical acts kind of like an x, except it has a value that we know of. So that is our coefficient. The next thing I want to talk about is the radical sign. Okay, so before we've called this a square root, which it's fine if you call it that, but you need to know the word radical. Okay, so if I say to put something in simplest radical form, what we're doing today, that's what I'm referring to. And then the radicand is the number underneath the radical. All right. Okay, so what I have on the top of your paper are the perfect squares up to 15. Okay, so again, all this means this is 1 squared, 2 squared, 3 squared, etc. Okay, so I don't know why these didn't show up, so I'll rewrite them in. So the first one we're going to do is the square root of 144. Well, hopefully you noticed that that's actually on here. So the answer to that is 12. That is a perfect square. Okay. The next one we have is negative 144. So another thing for you to know, when we are taking a square root, this number must be positive. Okay. So radicand must be positive. So not a real number. Okay. So if you were to put this in your calculator, so we're going to do the square root of negative 144. Okay, non-real answer. So again, always throw it in your calculator just to be sure. Okay, the next one we have, and yours are already filled in, I don't know why this happened on mine. Okay, so the square root of 9 and the square root of 121. Now, both of those are on here. Okay, so what you're going to do is you're actually going to simplify them separately, but keep them as a fraction. So the square root of 9 is 3, and the square root of 121 is 11. And that's your final answer. Easy as that. Okay, so we have the square root of 18. So what we're going to do now is we are going to rewrite this with a perfect square in front. Well, I know that 18 can be separated into 9 and 2. So I'm going to write radical 9, radical 2. Always write the perfect square in front, and then simplify that perfect square. Okay, so that is what you are looking for. Okay, so I have the square root of 20. So again, you can use this up here to help you out. Okay, so the square root of 20 I know can be separated into 4 and 5. Always put the perfect square in front and simplify the perfect square. Okay, the next one is 4 and 49. So what we're going to do is we're going to actually rewrite this as, so this is like the quotient of two perfect squares, and then simplify. Okay, and again, what really makes this a lot easier is knowing your factors. So I will say that if you do not know your factors, it will be a little more challenging, but not impossible. Okay, so we're going to use those numbers up top. So again, I'm going to take 68 and I'm going to divide it by the perfect squares. So if I do it by 4, okay, well this is this divides it evenly into, and 17 is a prime number, which means that the only other factor of 17 is 1 in itself. Okay, so this means that I have found the perfect square. Okay, so 4 and 17. So radical 4, radical 17. Perfect square is always in front so that it stays in the correct form. Okay, 8. Let's see. So this one you can separate. This one you can separate into 9 and 6. So we have the square root of 9 and the square root of 6. Perfect square in front. Simplify that and we get 3 radical 6. Okay. This is when I'm going to need the calculator. Alright, so 162. So we'll divide that by 4. Not a whole number, so we'll keep going. 162 divided by 9. So we get 9 and 18. So 18 is also divisible by 9, so I'm going to keep going. Okay, next one is 16. Again, I'm just taking these from that little chart on the top. Okay, so I'm just going to, put in the wrong 162. Okay, still not getting whole numbers. 6. Okay, And again, once you get better at this, you don't have to look anymore, and you can just find the right one. All right, so 81 it is. So 81 and 2 is what we separate this into. So, oh, 81, not 18. So 81 times 2, so we separate it, perfect square in front, and the leftover radical goes at the end. Okay, so now what we're going to do is we're going to keep this, whatever the number out is out in front, we're going to keep that, okay? And then we're going to work with our radicals separately inside. So I know that 32 can be broken up into 16 and 2. Okay, so now what I'm going to do is I'm going to simplify this radical, and then whatever's in front, those things get multiplied together for my final answer. Okay, so again, that number out in front, so the coefficient, we keep it out front at first, all right? This can be divided into 49 and 2. Simplify that, and then multiply your coefficients. Okay, so the difference about these examples is they have an additional coefficient. Okay, so you have to multiply those after. Okay, so we can separate this into radical 9 and radical 3. Simplify that radical and then multiply the coefficients. And again, just be careful of those negatives. Okay, if you have a negative out in front, your final answer will have a negative as well. So 9 and 8. Actually, I think we can go higher than that. I think we can go higher than that. 36. So 36 and 2. So negative 3, 6 radical 2. Multiply those in front, and we get negative 18 radical 2. Okay, again, 1/2 is no difference, just a number. Okay, keep it out in front. 64 and 3. So 1/2. So 1/2 of 8. That's how you say it to yourself. Then you can say, oh, it's 4, of course. So 4 radical 3. And 324, hopefully you see on the other page that that is a perfect square. So all we do is we evaluate that perfect square and get 18. Multiply those together, and my final answer is negative 90. Okay, so page number 9, numbers 1 through 6, our homework. Okay, let's do them now. Okay, I can help you, so please do them now in class.